This cicada should be dead. 2/3 of its body is gone, hollowed out, crumbled away, replaced by a dry white plug where its lower half used to be. And it is still flying. It lands on a branch and it does the one thing a dying animal should never have the strength to do. It tries to mate. It is not sick. It is not slowing down. It has never felt better in its short, doomed life, because something inside it is making sure of that. Something that ate its body and then drugged its brain to keep it happy about it. Host or hijacker, no one is safe. Its name is Massospora cicadina, and it is a fungus that has learned to do something no fungus should be able to do. It hunts the periodical cicadas of North America, the magic cicada broods that spend 13 or 17 years buried underground, in the dark, feeding on tree roots, waiting. These are not the ordinary cicadas that hum through a single summer. They are among the longest-lived insects on the continent, and they survive by sheer overwhelming number. When their time finally comes, millions of them claw to the surface at once, on one synchronized signal, to sing, to mate, and to die within a few short weeks. There are so many of them that predators simply cannot eat them all. Safety in a flood of bodies. It is one of the strangest life cycles on Earth. And the fungus has spent those same 13 and 17 years waiting for them, buried in the same soil, counting down to the same emergence. When the cicadas come up, so does it. And what it does to them is not infection, it is possession. But here is the question that should stop you cold. A fungus has no eyes, no brain, no nerves, no plan, no hands. It is a web of microscopic threads that grows where it can eat. So how does something with no mind at all take an insect apart from the inside, keep it flying, override its most basic instincts, and turn it into a delivery system that spreads the infection to everything it touches? How does a rootless, brainless smear of cells learn to pilot an animal? Because Massospora does not simply feed on the cicada. It rebuilds it into a machine that works for the fungus and against itself. And to understand how far that hijack goes, you first have to understand what happens to the cicada's body once the fungus is inside. It begins the moment a cicada brushes against a spore or tunnels up through infected soil. The fungus takes root inside the abdomen, the rear of the body, and it starts to eat. Slowly, from the inside, it hollows the cicada out. It consumes the organs. It consumes the reproductive organs entirely. And in the space it empties, it grows something new. A hard, chalky plug of fungal spores, packed where the back of the body used to be. The rear of the cicada, genitals and all, dries up, breaks apart, and simply falls away, exposing that white mass of spores to the open air. This should be the end. An animal cannot lose 1/3 of its body, cannot lose the organs it reproduces with, and keep going. But the cicada does keep going. One researcher who studies them put it plainly. 2/3 of their body might be missing, and they would still be whistling as they walk down the street. It flies. It sings. It searches for a mate with a body that is no longer capable of mating, carrying its own executioner where its abdomen used to be. It shows no outward sign that anything is wrong. And the fungus has one more thing waiting inside it. Not a spore, a drug. Because tearing an insect open is not what earns this story its name. Plenty of parasites eat their hosts alive. What Massospora does next is something almost no other organism on Earth is known to do. And it is the reason the cicada never stops, never slows, never seems to notice that it is disintegrating. Watch closely. This is the part that changes what you think a fungus is capable of. When researchers analyzed the tissue of these infected cicadas, they found it laced with a psychoactive drug. In the 17-year periodical cicadas, the fungus was loaded with cathinone and amphetamine, the same class of stimulant found in the cat plant that people chew to stay awake and alert. They measured it directly inside the bodies of infected cicadas. It was the first time an amphetamine had ever been found produced by a fungus. And there was a second twist. A related group of Massospora species that infect annual cicadas, the ordinary summer kind, were making a different drug entirely, not a stimulant. Psilocybin, the exact compound that makes magic mushrooms hallucinogenic, and this was the first time it had ever been found anywhere outside of a mushroom. Think about what that means. A brainless fungus, on two separate branches of its own family tree, independently evolved to brew powerful mind-altering chemicals, a stimulant in one host, a hallucinogen in another, and it manufactures them inside the very animal it is eating alive. No lab, no chemist, just a rootless organism that learned to synthesize drugs it has no nervous system to feel. This is where the title comes true. The fungus is feeding its victim amphetamines, and researchers believe it does that for one reason: to keep it moving. Because a drugged cicada is a busy cicada. Scientists strongly suspect, and this is the leading theory, not proven fact, that the stimulant keeps the doomed insect hyperactive and driven to mate long past the point where its ruined body should have quit. Think about what an amphetamine does. It floods you with energy. It kills your appetite. It keeps you awake and restless and moving when you should be exhausted. Now imagine that chemistry running through an insect that has already lost the lower half of its body. It does not rest. It does not stop to feed. It flies, and it searches, and it tries to reproduce, over and over, with a mass of spores where its reproductive organs should be. And every one of those attempts spreads the fungus. That is the whole point. The cicada is no longer trying to make more cicadas. It has been converted into a machine for making more fungus. Kept wired, kept willing, and kept airborne just long enough to seed the world around it. It shows no outward sign that anything is wrong. It behaves, right up to the end, as if it were perfectly fine. That is the horror, not the pain, the absence of it. Now watch how the fungus turns that drugged energy into a weapon. A normal male cicada finds a mate by listening for a female's response, a subtle flick of the wings that only a receptive female makes. It is the colony's private courtship code, and the fungus has cracked it. Infected males don't just chase females. They perform that female wing flick signal themselves, the one only females are supposed to make, luring healthy males in close for a mating attempt. The trap works on everyone. That means the fungus doesn't only spread through males chasing females. It spreads male to male, female to male, in every direction, and every single contact smears more spores onto a new host. It is, in every meaningful sense, a sexually transmitted infection, engineered by the fungus and broadcast by an insect it has already gutted. And because these cicadas emerge in the millions, packed together on every trunk and branch, the swarm becomes the perfect crowd for it to move through. Thousands of bodies brushing past thousands of bodies, each contact a chance to pass the spores along. Researchers at West Virginia University gave these creatures a name that says everything: flying salt shakers of death, because that is what they have become. Disemboweled, spore-packed, drifting through the swarm, raining spores from their open rear ends onto everything they touch. Now pull back, because the fungus is not thinking in weeks, it is thinking in decades. Massospora runs a two-stage cycle, and both halves are patient. In the first stage, those freshly emerged, drugged, hypersexual cicadas produce sticky active spores that spread from body to body by contact during the emergence. The fast, contagious phase that sweeps through the swarm in real time. But the cicadas infected in that wave develop the second stage, a tougher, more durable kind of resting spore. And those resting spores do something almost unbelievable. They drop into the soil, and they wait. Not for days, not for a season. They lie dormant in the ground for 13 or 17 years, through everything, until the next brood of cicadas finally tunnels up through that same earth, and the whole cycle begins again. The fungus keeps the same calendar as its host. It has been synchronized to this doomsday clock for so long that it emerges on schedule, generation after generation, always ready, always waiting in the dirt beneath your feet. And there is one last detail, the one that makes this feel less like a disease and more like a design. Step back and look at everything the fungus accomplishes at once. It takes the body, hollowing the cicada out and replacing it with itself. It drugs the mind, brewing an amphetamine to keep its victim tireless and eager. It weaponizes reproduction, hijacking the courtship signal so the infection spreads in every direction through the swarm. And it does all of this while the host shows no sign of distress at all. Flying, singing, reaching for a mate, feeling, as far as anyone can tell, perfectly fine. This is not a parasite that kills its host and moves on. It is a parasite that keeps its host alive, active, and eager precisely because an active host spreads more spores. Most predators want their prey to stop moving. This one needs it to keep going. It has no interest in a quick death. A dead cicada carries nothing, meets no one, spreads nothing. So it does the opposite of killing. It sustains. It keeps the doomed insect on its feet and in the air, cheerful and driven, for as long as there is any use left in the body. The cicada isn't fighting for its life. It thinks it's living it. And the most unsettling truth of all is that it never knows the difference, right up to the moment there is nothing left of it to know with. If a fungus that drugs its victim into a cheerful death unsettled you, then you are not ready for what crawls up next, because this one doesn't just take the body, it takes the eyes. There is a parasite that invades a humble snail, worms its way up into the snail's eye stalks, and fills them with pulsating candy-striped sacs that swell and throb like fat green caterpillars. Then, it seizes control of the snail's brain and drives it out into the open, into the daylight, into the last place a snail would ever go, so that a passing bird will see those throbbing eyes, mistake them for a meal, and pluck them clean. The snail never sees it coming. It cannot. Its eyes belong to something else now. Watch that video next. Subscribe, because every week we open another lid you cannot close again. Host or hijacker. No one is safe.